Hello everyone, welcome to the microcontroller lab sessions. In the previous sessions we had looked in terms of different types of arithmetic operations such as addition, subtraction, squaring and all those things. In today's session we shall look in terms of logical operations, how actually we can perform the logical operations that we are going to discuss in this particular session. Now let us look into the program. Here you can observe what type of program that can be asked in terms of logical operation. Okay, here you can observe they have said us to take they have said us to perform the logical operation in terms of what? In terms of ports. You can observe over here, right? So here you need just have a look at this particular thing over here. Okay, let me roll back. You can see this. They are telling us to perform the operation need to be done at the P1 port and it should be done at P2 port, and the result what we are going to get, it has to be performed on P3 port. So what I'll be having, as we know our ports what we are having, if you consider P1 port, even this is going to be a 8-bit port, and then P2 port is also a 8-bit, and then P3 is also a 8-bit. So all these particular ports are what? They are a 8-bit. So basically here we are going to perform a byte operation. Byte operation is nothing but what? It is going to be a 8-bit operation what we are going to perform. Okay, so now if you look at this, what I should do, I'll be having some value at port 1 and I'll be having one more value at port 2, and then I need to perform logical operation. That can be it can be what? It can be AND gate. So it can be an AND gate, or it can be a OR gate or XOR gate. Okay, so the result what I am getting after performing this particular operation, the result what I am getting, it is going to be stored, it has to be sent to port 3. So how actually we are going to perform these operations, that we are going to see now. Okay, so how actually to write down the program, that also we are going to see. Now let us look in terms of flow, what are the steps that need to be followed in order to perform this operation. Okay, so now if you are going to perform that particular operation, first what I should do, I need to get the data. First I should make sure, since my P1 and my P2 are going to be input ports, so I need to send the data for these particular ports with the value 0FF hexa. Okay, so once I have sent these values, I have sent the value 0FF hexa to P1 and then P2, then these particular ports will be acting like what? They will be acting like as an input port. So this is going to be the first part, and the next step what we need to do is, I'm having one more port that is going to be P3, and this has to act like an output port. So this can be performed by sending value 00 hexa to the port P3. Now once you have sent the values, uh, once you have sent these values to P3, then I'll be getting, first I'll be taking the value of P1. The P1 will be loaded to A, that is my register A. After that, what I'll be doing, I'll be performing my AND operation. As we have considered an AND operation, I'll be performing AND operation with A, comma, what I'll be doing, I'll be taking my another port value, that is going to be P2. Once you have done with this particular operation, then what I'll be doing, I'll be sending, because the result what we are going to get, that particular result, it is going to be present in this particular register. Once you have got the result, then what we can do, I'll be sending that particular value. The value is present in A, and then I'll be sending from A to port P3. So these are all different types of steps. Now let us look into the programming, how actually we can program this particular thing. So let me start off with uh, ORG00 hexa, right? So the initial point, what we are going to do. So and then I need to make sure that my port P1 and then port P2 should be acting as input ports. So how we can do is that I'll be loading the initial value to my register A. So I'll be loading, let me load this with 0FF hexa, and then I'll send the same value to my port P1 comma ARL perform. So the value what I'm having at A, that has been sent to P1. The same thing should be done in terms of P2. So I'll be doing P2 comma A. So here we have made our both the ports to work in terms of input ports. Now I need to perform the same operation in order to make my port P3 as my output port. So what I'll be doing, since A is having FF hexa value as of now, I'll be moving with 00 hexa. Okay. So once you have loaded A with the 00 hexa, then I'll be performing what? I'll be performing move P3 comma A. So now P3 has been sent with the value 00 hexa, so that it can act like an output port. Once we have done this, then what I should do, I should perform the logical operation. Then I should take the values which are present in P1 and then P2. Since P1 and P2 both are acting like what? As of now they are acting in terms of input ports. So I need to get the data. So I'll write move A comma P1. I'll write. So the data which is present in P1, that will be loaded into my register A. Then I need to perform the AND operation. So in order to perform AND operation, we are having an instruction something called ANL. So I'll write ANL comma P2. So it will get the data from P2, and then it is going to perform the AND operation with the content which is present in register A, and the result will be stored in register A itself. Now the result I need to send it to P3. So I'll write move P3 comma A. Okay. So this will send me the data to what? It is going to send the data with to my port P3. So this is the program. So basically what we have done, basically we have made our P1 and then P2 ports to be both P1 and P2 to be input ports, and then we have made our port P3 to be output port, and we have performed, we have bought the data from P1, and then we have bought the data from P2, and then we have performed AND operation. The result what we are getting, that is being stored where? It is being sent to port P3. Now let us build this particular program. So here you can observe there are 0 errors and 0 warnings. Then let me go in debug mode. Okay. So once you are there in debug mode, let me open these peripherals what I'm having. So let us go to these peripherals, IO ports. Since I have used port P1, so I'll take this port P1. Okay, and then I have port P2. So again I'll go back to this peripherals, and then I'll tick on this port P2. So I'll get this port P2, and then port P3 also we have used. So let me take that port P3 and then let me take it over here. As you can see, all these have been loaded at the reset condition. You can observe that these particular pins or these particular ports have been loaded with the value what? FF hexa. That means all these ports by default they will be acting like what? They will be acting as an input ports. Now let us go with the step by step. So in order to perform step by step operation, here you can observe, either you can go to this particular symbol over here, or you can perform with the shortcut key, that is to be F11. So now let me start with F11. Now you can observe A has been loaded with FF hexa value. Now P1 has been loaded with FF hexa, P2 has been loaded with FF hexa. Now A has been loaded with 00 hexa, and then what I will take, I'll be doing see, now port P3 is being working as what? It is being working as of now it is going to be output port. Now if you take a look at this, I have made the, let me take the 0th bit itself. Now if you look at this 1 and 1, it is going to be what? It is, if you perform 1 and 1, the output will be 1. But at the 0th bit what we are having, this is going to be 0, and then this is going to be 1, 1 and 0, that is going to be 0, right? So now if I perform, the output will be what? The output will be FE now, as of now. Okay, now if you look at this, you can observe port P3. See here, the value has been changed. Port P3, you can observe the output has been changed now, right? So similar way, let me take back this again. Okay, so let me run this. Okay, now here once P1 has come, let me remove these values over here. Now what the value will be getting at bit 1 and 0, you will be getting 0 over here, and then at bit 5th again you will be getting 0. Okay, rest all other bits will be 1. So 1 and 5th bit is going to be 0. Now after performing the AND operation, you can observe the bit 5 and then bit 1 is being 0. So this is how we are going to do the AND operation. In the similar fashion, if you want to perform OR operation or XOR operation, so let me keep back this in a loop. So I'll write H1 over here. So let me take this as a loop, and then I'll give short jump H1. Okay, so if you want to perform any other operation, let me take XRL. If you want to perform OR operation, then I'll be using ORL. So again, let me rebuild the program. So here you can observe it is 0 errors and then 0 warnings. Now again, let me go in terms of debug mode. Okay, so let me start with the program. So here both the things have been made as input ports. Now here you can observe move A comma P1 OR operation we are doing. So let me remove the second bit. Here all 0 or 1, it will be 1, 1 or 1, it will be 1. So let me remove this as well. So 0 or 0, it is going to be 0, and then 0 or 1, it is going to be 1. The result what we will be getting, it is going to be all ones, and the last bit what we are having, that is going to be 0. Now if you look at the result over here, A has been moved with FA, and then it has been performed. The value what I will be getting, it is going to be FE. The result you can observe over here. Okay, now if you want to go back to the main, so let me change the values again. So I'll change these values something like this. Okay, now if you change the values, now again it will load that P1 value with the value what we are having, and then again if you look at D6. Okay, now if you perform D6, the result what you have got, it is going to be F6. Okay, and the result what you have got over here. Now if you can verify 0 or 0, it is going to be what? It is going to be 0, and 1 or 1, it is 1, 0 or 1, it is 1, again 0 or 0, it is going to be 0, rest 0, 1, rest all is any of the thing is 1. So you will be getting all ones over here. Okay, so this is regarding OR operation. Now in the similar fashion, If you have been said to perform XOR operation, then the value what I can give is the instruction is going to be XRL. So the XRL will perform XOR in debug mode. Okay, now let us see that we are having this particular thing. So it has been changed as of now. So 1 XOR 0, it is going to be 1. 1 XOR 1, it is going to be 0. So let me remove some two these things. So at the fifth bit, you are having 0 and then 1, and at the first bit you are having 0 and 1. So here the value what I should get, the first bit and the fifth bit should be what? It should be 1 1. Since all the bits are 1 and 1, okay, so 1 XOR 1 will be 0, so rest all the bits will be zeros. Now if you perform this operation, you can observe the fifth and the first bit are being 1. So this is how you are going to perform XOR operation. Okay, now in the similar fashion, here whole byte of data, if you look at this, we are performing the operation on whole byte of data. Okay, in the similar fashion, they will not ask you in terms of there are scenarios where you will be asked in terms of this. Okay, so here what they have done, get the data from P1 and then P2, and then the result should be sent to P3. Okay, but here they are telling that consider this perform this should be what, it should be a bit operation. So here I won't be taking in terms of whole byte of data, but the logical operations what we are doing, it is going to be what it should be in terms of bit operation. So how actually we are going to perform bit operation, that we'll see. Okay, now if you look at this, now again they have said that this should be what, I need to take P1. Okay, let me roll back this. Okay. So they have asked me to take the values from P1. Okay, now if you look at this, I again what we are having both the ports P1 and P2 to be what, the input ports, P3 to be what, the P3 should be the output port. Okay, now since P1 and P3 to be output ports, but since they have said us to perform in terms of bit operation, I can consider that I can take any one value, that is going to be P1.2. So this is going, since if you take a look at your ports, so P1 is a 8-bit port, right? So this is going to be a 8-bit port. In this particular 8-bit, I'll be using what? I'll be using the second bit. Okay, this the third bit in terms of this thing. So the third bit we are using in terms of as an input port, and then I'll be performing the same operation in terms of P2. Let me take this P2 to be what? I'll take this P2 to be, let me take this as P2.5. Okay, so port P2.5 I'll be taking, and the result of these, the logical operation result of these particular ports, I'll be sending it to, let me take this to be P3.7. Okay, the last bit what we are having, I need to send that particular value to P3.7. Okay, now how, what and all are the steps we need to follow in order to perform this operation, that will let us see those operations. Okay, before that let me remove this. Now how actually we are going to do, as we know, I'll be taking P2 point, I need to get the data from P2.3, and then I need to get this, we had taken P2.5, right? So P2.5, and then I need to get the data from P1.3. Okay, So both the datas I'll be taking it to what? This is going to be the first point. So I need to get these datas into my register A. So both the values. So the step remains same. So first I'll get the data from P1. Okay. But here, here what you need to do is, here actually we won't be using our register A. So since I'm having the bit addressable, we are having this carry flag, right? So we are having this carry flag. So I'll be taking use of this carry flag, and then I'll be performing those operation into this carry flag. So first what I'll do, I'll get the data from P1.3 to my carry flag. So this is going to be the first step, and then I'll take the data, whatever the data is present on this P2.5. So we had taken P2.5 to be another port. So I'll take the data from P2.5 and I'll perform the logical operation to this C. So here you will be performing what? If let me take, I am performing OR operation. So here you will be performing OR operation with the data which is present in C. Okay. Once you have performed the value, the result, if you look at the result, if you are looking at the result will be stored where? It is going to be stored in C itself. Okay. So once you have got the result, then what we will be doing? I'll be taking this result and I'll be sending to my P3.7 port to the value which is present in C. So this is how actually we are going to perform those operations. Now let us see how to write down the program. So again here you can observe that as we know, you can observe something like this, what and all. So if you want to perform what, if we want to perform this step remains same. Okay, rest all is going to be same, only this part what we are having, the step 2, that is going to vary. So if you are performing OR operation, then I'll be using, see, if we are performing AND operation, let me take, if I am performing AND operation, the instruction what I'll be using ANL. And if you are performing OR operation, then the instruction what I'll be having, that is going to be ORL. And if you want to perform XOR operation, then that is going to be what? It is going to be XRL. So this is going to be the instruction. And if you want to perform NOT operation, okay, then CPL is going to be what? The CPL is going to be the instruction. Okay. So now let us look how actually we are going to perform this operation. Now we'll start off with, let me take the same question and then let me paste it over here. Okay. So considering, so first what I'll be doing, let me take, we'll be starting off with ORG00 hexa, and then I need to make my input port and then output port. So we'll be taking move a comma hash 0ff hexa, and then I'll be making my port P1 to be input. So I'll move P1 comma a, and then I need to make my port P2 as well as an input. So I'll be making P2 comma a. Now I need to make my port P3 to be a output port. So I'll be sending move a comma hash 00 hexa, and then I'll be sending the same value to P3 so that P3 can be activated as an output port. Now we need to get the data. So what I should do, I need to get the data P1, port P1 dot 3, where it should go, it should be going to my carry flag, right? So move C comma P1 dot 3 I'll write. Okay, so this will take me the data which is present in port P1 and third bit. And then I need to perform, let me start off with AND operation. So I'll be using ANL C comma P2.5 I will write. So here it is going to perform AND operation on the P2 port with fifth bit, and then the same data has to be sent to my P3.7. So I'll write move P3.7 comma C. Okay, so let me take this in terms of a loop. So I'll write this as H1 so that it can be used as a loop over here, and then I'll give a short jump where it will be jumping to H1 back again. Okay, so let me end with this with the end. So let me build this program. So here you can observe the data has been built and with a 0 errors and 0 warnings. Let me go in debug mode. You can go debug mode in terms of here debug. Okay, uh, either you can go debug, start and stop debug. Here I am using the shortcut key, that is going to be Control F5. Okay, so I'll press Control F5, so it is going to take me into the debug mode. In the similar fashion we are having over here, so I'm having P1 and then P2 and then P3. Okay, so here basically we will be using this P3 port, P1.3. So this is going to be P1.3. Okay, and then I'll be using P1.5, P2.5. This is going to be P2.5, and then this is going to be P3.7. Okay, so now let us go in terms of step by step. Let us do these these things. So we have made P1 to be input port, and then P2 to be input port, P3 to be output port. Now since I am using P1.3, so let me take this as 0, and then I'll make sure that my P2.5 is going to be 1. So 1 XOR, or let me take this, let me remove these values. Okay, so 1 XOR 1 and 0, that is going to be what? It is going to be 0. Okay, so now if you look at this, after performing the P1 carry flag, if you look at this P1.3, so P1.3 is 0, so 0 has been loaded, and then after performing your carry flag is still 0 because 1 and 0 is going to be 0, and the same has been sent over here. Now let us see that we are having what? Let us see. I'll make sure that P1.3 is going to be 1, and then this is going to be 1 as well. So after this it is going to come back over here. So now you can observe carry 1 P1.3 has been loaded with what? With a value 1. 1 and 1, if you look, so 1 and 1 is going to be 1, so P3.7 will be loaded with the value 1. Now this is for what in terms of same. Let us see in terms, even the OR remains same. So let me take this in terms of what? In terms of XOR operation. So XOR L, C P2.5 I have done. So let me take in terms of OR operation. I cannot perform the XOR operation. Okay, so let us go in terms of this, and again let me make this, let us do all these steps so that it comes back to this. So let me take these as 0 0. Okay, let me do it as 0 0, and then let me make this as 0 0. Okay, so you can observe because already C1 has been loaded. Okay, 1 or 1 it is going to be 1, or 0 it is going to be what? It is going to be 1 only. So you can observe P3 has been loaded with 1. Now let me go back over here, and then let us perform whether 0 or 0, whether it is going to change. Now you can observe 0 or 0, your value has got changed over here. So this is terms of bit addressable, then we'll be making use of the carry flag. And if you are being said in terms of byte addressable, then we'll be taking whole port value into the register A, and then we'll be performing these logical operations. In the next class, in the next session, we shall look into the next programming part, that is conversion of ASCII to binary, and all the parts what we are having, that we are going to see in the next session. Thank you.